All right, let's get to work on some more composite volume. And remember, this is a difficult skill. So if you're having trouble, just keep watching the videos, pause it when you need to, rewind it, go back and look at other examples to help you through the way. And again, I'm going to put a picture of the answer sheet for your practice problems in this video so you can self-check and go back and look at it if you need help. And then when you come back to class, we're going to also practice these so you get more and more practice and have me there to support you if you need help. Just do the best you can. All right, so today we're going to use what we did yesterday, and the prisms were already separated for us, but you'll notice on this new prism for today, there's no separation. They're just attached together like a rectangular prism. So we have to detach them on this two-dimensional paper in our mind three-dimensionally. So when I look at this first picture, I see a big cube sitting on top of a rectangular prism. So I'm going to take a ruler and I'm going to split these prisms in half. So I'm going to extend the lines. I'm not going to bend anything. Any line I draw is going to be an extension of another line or edge. So I'm going to extend this edge right here and close off that. Now I can see my cube sitting on top of the rectangular prism. I'm going to use my colors again because that helps me to visualize the two prisms on top of each other. And again, if the color doesn't help you, you don't need to use it. It's just there to help you if you need it. It helps me out a lot when I see my prisms. Okay, so this cube that's sitting on top, if it's a cube, it has the same dimensions in all three ways. So it has the width, it has the height of 6, and it has the length of 6. All of those, width, length, there's length, and height are all 6. So the volume of this figure 1 would be 6 by 6 by 6. We actually did this multiplication problem yesterday. 6 times 6 is 36 times 6. I'm going to come over here and do that one. Give me some more room. 6 times 6 is 36, and 6 times 30 is 180. And just like yesterday, you may use a calculator to help you with the multiplication if you need it. Or you can do the multiplication and then self-check it with a calculator to see if you're correct. Okay, so here's our figure 2. We have the length of 10, I have the width of 6, and I have the height of 4. Everything's there for me. So I'm going to do 10 times 6 is 60, then multiply by 4. 6 times 4 is 24, and the 0 for the 10. So that's 240 cubic centimeters. To find the total volume, the composite volume, we're going to put those two figures together and add them up. 456 cubic centimeters. Now that one wasn't too bad because all of the dimensions were there for me. I didn't have to go search for any. All right, so now I'm going to go to this next one. This one, I have to think about which way I want to separate it because I actually see two different ways. I can see if I extended this line down, I'm going to extend this line, I see a tall rectangular prism standing side by side with this one laying down. I could use this one, but here's a little hint. I already have this 12 centimeters written for the whole bottom, and if I split this one off, I'm going to have to find these two lengths here and split them. I also don't know this entire length here because it was broken up in others. So I think I'm going to divide it in the other direction. I'm going to put a box or a prism sitting on top of a long rectangular prism. So I'm going to extend my line this way, and I'm also going to do my width just like that. So I have one cube on top, or it's not a cube, I'm sorry, one on top of the other. Okay, so let's use that to find out. So here's my figure 2 and my figure 1. I'm going to use my shading. Shade that cube on the side, and I can see already I'm going to need to do some finding of this shape here. So let's take a peek. If I have figure 1, first thing I need is this length right here. Now, opposite side doesn't tell me, and opposite side doesn't tell me. This 4 is not the measure of these. It's the measure of the depth or width. So I can't use that 4. I need this measure right here. So in order to find that, I'm going to have to figure out here to here, this, and then use the opposite side. So the opposite side is 12 centimeters, and I know this is 9 centimeters. So if that's 9 centimeters, the rest of it has to be 9 plus 3 is 12. So this has to be 3. So the length of this one is 3 centimeters. Again, because this distance here plus this distance here, 9, and the length of 3, put those two together for 12, that equals the total of the rectangular prism. So now I have all three of my measures, length, width, and height. So I can do length times width times height. 3 times 4 is 12, times 4 is 48. So figure 1, I have 48 cubic centimeters. So for volume 2, see, is it a little blurry on you? There we go, it's a little better. For figure 2, let's cross these out now because I don't need them. I need the entire length of this white box, which is 12. So that's 12 by the width. Well, the width isn't here, but if I follow opposite side, not there, opposite side, it's 4. Because the width is the same for all of them, all the way around. And then the height is 5. Okay, so I'm going to use 12. I'm going to do 4 times 5 first to get 20. Then 12 times 20 is 240. So figure 4 is 240 cubic centimeters. My total volume, I'm going to add those up. 288 cubic centimeters. Cubic centimeters. Now I'm going to show you that just one other way because you can do it both ways. Okay, so I'm going to take a look at that same question again, and we're going to split it this time going down instead of one on top of the other. So instead of drawing my angle to the side, I'm going to draw it this way. So now my figure 1 looks a little different. I need the length here, which remember we found out if this is 12 and this is 9, this has to be 3 because together 9 and 3 have to make the 12. Then my height on this side, I don't have a height neither here or here, but I do know this is 4 and this is 5. So 4 and 5 together would make 9 centimeters for my height. And then the length is 3, the width is 4. So I have 3 by 4 by 9. That's 12 by 9, which is 108 cubic centimeters. Now I come over to this rectangular prism, and it's a 9, not 12, because I only need from here over. So it's 9 by the width. The width, I have to go all the way up here to find the width, is 4. 9 by 4, and the height is 5. So I'm going to do 4 times 5 first to get 20, and then multiply my 9 to get 180. If I add those together, I get 288 cubic centimeters. Now look at those side by side. Notice how I did them differently. This one I saw cubes or rectangular prism sitting on top, and this one I saw two side by side. My total volumes, I had 48 cubic centimeters because it was smaller, and then this one was larger, so it was 240. Whereas on this one, I had 108 because it was larger and 180. But if you'll notice, the total volume for both of them is 288 cubic centimeters because it's the same thing no matter which way I split it, as long as I use the correct dimensions. Volume is always length times width times height, all the time. All right, let's try another one. Here's another L-shaped composite prism. So I have to decide which way I'm going to split it. And for this one, I think I'm going to split it this way. I'm going to have one standing beside the other one. So I have these two prisms, figure 1 and figure 2. So this one I need length, width, and height. Well, I need the length to here, but 14 is from corner to corner. I don't need that. I only need to here. So in order to find this, I have to figure out this as well. So if I go straight up, I say, well, that's 4 centimeters. So if this is 4 centimeters length, and altogether it's 14, then this has to be 10 centimeters. There's my length. I have my height. I just need the width. So let's look around the prism until we can find the width. Right there, 2 centimeters is the width for our prism. So figure 1, I'm going to use length, 10 times width, 2 times height, 5. I get 10 here times 10. Figure 1 is 100 cubic centimeters. Figure 2, my length is 4, my width is 2, and my height is 10. 4 times 2 is 8, times 10 is 80 cubic centimeters. So the total volume is 180 cubic centimeters. Okay? All right, one last one together. Let's see if we can get this last one. I'm going to raise it up. This one I have a very large cube next to a smaller cube. So I think for this one, I'm going to just break off this bottom piece right here. Right there so I can see them. So I have for this box, I have the height. I don't have the length for it though. I do have the length from this corner to this corner. That's the length. But I only need from here to here. So I'm going to look and figure this one out and go up to the opposite sides and see 2 is the length of this. So I'm going to put 2 centimeters there. And if it's 14 from vertex to vertex, this remaining part has to be 12 centimeters as well. So 12 and 2 makes our 14. 12, oh, it does look like a square. I wonder if it's a cube. Let's find out our length. We need our width. This is the width. Not there, so I have to follow around the rectangular prism until I find a width. 12. Well, look at that. We have a cube. 12 by 12 by 12. 12 by 12 by 12. This one's going to be a little bit more difficult multiplication because 12 times 12 is 144. And then we're going to multiply it by 12. So 144 times 12. I'm going to come down here and use the area model because I know 144 times 12. This is what you used in 4th grade. We're going to work a little bit later on the algorithm, but for now we'll use this since it's what you're used to. And remember, for this activity, you can use a calculator to help you to solve your volume. So I have 1,000, 200, 400, 80, 40, and 8. 8, 12, 7, 1. 1,728 cubic centimeters. Notice how much larger this number is for volume. But this is the first time we've had such large dimensions, 12 centimeters. I'm multiplying 12 times 12 times 12. And remember, as these dimensions get larger, the volume grows exponentially. It's a very fast growth. Okay? All right, let's check this one. I have my length already. I'm going to bring this down here and give me some room. I have 2 centimeters. Length times width, 12, times height, 3. I'm going to use the commutative property here and multiply the 3 times the 2 first and get 6, and then multiply it by 12. 12 times 6 is 72. So my volume is 72 cubic centimeters. So now I just need to add them together. 1,728 plus 72, 1,800 cubic centimeters. And again, a much larger volume because I'm using much larger dimensions. Okay? All right, so now what I would like you to do is try the back side of this paper. It's just like the front side, the same thing that we've been doing, exact same thing. You're going to find a place to split the rectangular prisms and then find the volume of each one, and then we'll go over it. I'll have an answer sheet down below so you can go back and check.